let's find the power series expansion for the function 1 over 1 minus 3x. This is very similar to our best friend already because the 1 match, this 2 1 match, and also the subtraction match. So we can purposely look at this function as 1 over 1 minus the 3x in red because we just have to plug in the 3x into this x and then on the right hand side as well. And let's go ahead and do that. This will be 1 plus, instead of x, now we have 3x. So let me put down 3x, and then we have another plus 3x, we put that in the parentheses, and then raise that to a second power. So it looks like this, 3x to the second power. And then the next one is going to be plus, putting 3x in a parentheses for this x, and then raise to a third power. 3x in here to a third power. And this keeps on going forever. And now let's simplify the power. This is going to be 1 plus 3x. This is plus 3 squared, which is 9, and x squared. And then we have plus 3 to a third power, which is 27, x to the third power, and so on. In a more compact form with a sigma notation, we can write this as sigma as n goes from 0 to infinity. And then we just need to plug in 3x into this x. Use a parentheses first, and then 3x inside, raised to the nth power. And we will have sigma when n goes from 0 to infinity, 3 to the n power times x to the n power. And this is the form. That's it. But now let's talk about when can we really use this equation. Well, the original condition was our best friend was true only when we have the absolute value of x is less than 1. But then let me just write this down. This is true only if the absolute value, earlier we just have x for our best friend, but then we plugged in 3x into our x right here. A quick way to find the radius of convergence, because we use our best friend, we plug in things, right? We can just plug in 3x into this condition. So we have this is true only when we have 3x in the absolute value to be less than 1. So it's pretty much the same as using our best friend. This way, we don't need to run through the ratio test. Even though we could, assuming that we didn't do any of this, maybe somebody just tell me this is the power series and ask me to find the radius of convergence for them. And I have to use the ratio test for that. But then I didn't need to do it because I use our best friend. I just plug in 3x into the general form. So we can also plug in 3x into this right here to find the radius convergence. But then the radius convergence, it's not 1 because we have to isolate the absolute value of x. So we have to do some algebra right here. So absolute value of 3x is the same as saying we can take out the 3 times the absolute value of x to be less than 1. And then divide both sides by 3, we have absolute value of x to be less than 1/3. 1 over 3, right? Like this. Let me just put it down like that. So this right here, after the absolute value of x is isolated, we know that the radius of convergence is equal to 1/3. Okay? And now let's talk about the interval of convergence. Our best friend, it converges only when we have -1 to 1, and we didn't include the endpoint. And then because we are only doing algebra by plugging the 3x into our best friend, we are not going to include endpoints as well. So the center is also at 0 because as you can see, this is x minus 0, pretty much. And then the radius converges 1/3. That means we can go out 1/3 to the left and then go to the right 1/3, which will end up with -1/3 here and then +1/3 here. And we also do not include the endpoint because once again, we're just following our best friend. And then anything inside of -1/3 to +1/3 will converge. So we can use this formula right here. So this is actually just like a quick way because we are just using our best friend with our just like a blueprint. But then one thing you have to be careful is that we can only do this kind of things only when we just directly plug in, let's say, 3x into our best friend. If we are just trying to differentiate or integrate our best friend to get a new function, to get a new series, we must check the endpoints to see if it converges or not. But interval convergence, radius convergence, and then the form. That's it.